Yes, dear students, there is question actually from NCERT book. It is 10.11. Actually, in new editions, this question has not been given, and such questions should be solved. Water is flowing through a pipe of diameter 1.25 centimeter. Sorry, and density water 1000 kg per meter cube, viscosity 10 to the power minus 3. You have to determine the nature of flow. Nature of flow means streamline or turbulent. In two cases, number one, if rate of flow of water, number one is 0.48 liter per minute, and number two, 3 liter per minute. Pipe has diameter of only 1.25 centimeter. Density was 1000 and viscosity 10 to the power minus 3 Pascal second. If rate of flow is 0.48 liter per minute and 3 liter per minute, then what is the nature of flow? So nature of flow is by Reynold number. And you know Reynold number. Let me repeat. You know R E equal to V into rho into diameter upon. So we need V here. And you know there is a pipe of a area A, and water coming out of this velocity V per second, meter per second. Then volume of water flowing per minute per second. That Q is equal to A into V. It is the volume of water or liquid coming out per second. मैंने पहले बताया था. So here you are given this, and remember 1 liter. 1 liter, how many meter cube? 10 to the power minus 3. Liter is the unit of volume. Meter cube. Liter is the unit volume. 10 centimeter by 10 centimeter. Any 1 decimeter cube 1 liter होता है. तो फर्स्ट केस में हमारा जो Q है वो है 0.48 लीटर 10 to the power minus 3 meter upon minute 60 second. We have to take it in meter cube per second. So then 10 to the power minus 4 or minus 2, so it come out 8 into 10 to the power minus कितना भाई 6 meter cube per second. It is the rate of flow, and Q is equal to A into V. So from here V is equal to Q upon A, यानी कि 8 into 10 to the power minus 6 upon pi d square by 4. This 4 above to 32 into 10 to the power minus 6 upon pi d square. So we have to find out RE. Putting this value of V here, we get RE is equal to V is 32 into 10 to the power minus 6 upon pi d square into rho 10 to the power 3 density diameter में रखता हूँ ऐसे ही, और इसको 10 to the power ये प्लस 3 माइनस 3 इससे स्क्वायर हट जाएगा, ये आसान होता है. एंड देन इट इज 10 to the power 6, तो पावर कैंसिल, तो इट इज 32 अपॉन 3.14 into 1.25 centimeter minus 2 meter. So how to solve 32 into 100 or into 100 ये upon 3.14 into 125. 25 5 जा 4 जा और 20 जा. So it comes out to be 4 to the 8. 8 to the 16 or divided by 3.14. So it come out 3 8 24. It will come out 800, Google's answer 815 है, but if I divide here, it will be something different. Anyway, if Reynold number less than 1000, the flow is streamline. So if the water is flowing at rate of 0.48 liter per minute through a pipe of diameter 1.25 centimeter, then flow is streamline or laminar. Now we come to next, if flow rate of flow is 3 liter per minute. 3 liter per minute. So A into V, 3 into 10 to the power minus 3 meter cube per second, 60. It is so 1 by 2 into 10 to the power minus 4 or 5 into 10 to the power minus 5 liter per second. Again, so it is pi d square by 4. A जो रेडियस होता है, एरिया होता है पाई आर स्क्वायर, ये डायमीटर का डायमीटर आर इक्वल टू पाई डी बाई 2 तो स्क्वायर होगा. तो फ्रॉम हियर इनटू वी, सॉरी, तो वी कम आउट टू बी इक्वल टू कितना होगा भाई, दिस वी विल कम आउट हियर इक्वल टू 4 5 20 into 10 to the power minus 5 upon pi d square. Again put the value here. So RE comes out to be B, 2 into 10 to the power minus 4 रहेगा upon pi by R. तो धोखा दे रही, pi into d square rho 10 to the power 3 और into d, d है विस्कोसिटी 10 to the power minus 3. तो d कैंसिल, पावर ये होगी 6, तो कितना बनेगा 6, 2 होगी प्लस की, तो 200 3.14 into 1.25. So it is 2200 into 100 into 100, so 10 to the power minus 2 upon 3.14 into 125. 25 4 ja, and this is 20 ja. So it is how much? 4 दूनी 8, 8 दूनी 16, yes. तो 4 दूनी 8, 16,000 बटे 3.14. So it will come out here 5,095, which is more than 1,000. So this flow will be turbulent. So this was all about the critical velocity, Reynold number, and other things. Now I will take next video important thing, that is Stokes law. I can finish it here also. Let me finish here. Now I come to Stokes law, the same. Stokes law. Stokes law. Actually this S is the name of Stokes. नाम ही Stokes है. नाम ही Stokes. है भाई? What's the name? Stokes ने मैंने लिख दिया. C नहीं है. पहले ठीक था. स्टोक्स लॉ, तो नाम ही स्टोक्स है भाई। और जब नाम में सतत ऐसा क्या होता है, स्टोक्स लॉ। तो व्हाट दिस लॉ स्टेट्स, दिस सिंपल लॉ हियर, एक्चुअली when any spherical body, like this I am taking here one diagram, because it is easy to allow any spherical body to fall to viscous liquid. It is spherical body of radius r. So when this spherical body move downward or upward in whatsoever direction, if velocity this way, then viscous force upward. If body moves upward, viscous force downward. So when a spherical body moves through a viscous liquid, then a retarding force, यानी कि force opposite to velocity, retarding force opposite to velocity acts, a retarding force acts on the body. This force is given by F equal to 6 pi eta RV, where what is R? R is the radius of sphere, eta viscosity of liquid, and V is the velocity. When body will move with increasing velocity, force will also be increasing. This is called Stokes law. It applies only when spherical body. We talk about spherical body. This is very important here. As velocity increases, viscous force increases. Thank you.